My great pleasure to welcome today's speakers, Alejandra Ortiz and Alison Bates. Although Aleja and Alison are both assistant professors of environmental studies at Colby, they might seem very different in terms of the kinds of research that they do. For example, Alison is a social scientist who studies, among other things, social acceptance of infrastructure and interventions in natural spaces, especially by implementing an equity and justice framework to inform decision-making. She's worked extensively on renewable energy issues, where if you haven't noticed, it's clear that people differ a lot in terms of how they think about renewable energy, right? On the other hand, Aleja is a physical scientist who studies how landscapes change, especially landscapes that are shaped by water, like coastlines and lake shores. So her expertise is crucial for understanding things like the physical impacts of sea level rise, but as you'll see, also to designing strategies for reducing algal blooms in lakes, and that's a story you're going to have the chance to learn about today. Both Aleja and Alison are outstanding researchers in their own rights, in their own areas of expertise, but one of the really exciting things, to me at least, is the way they have joined forces to address problems that require a focus on how people interact with the natural world. This is crucial not just for understanding sustainability problems, but especially for developing and implementing solutions to those problems. And I'll just say for the record that that's why the Mitchell Center was created. That's what we try to do every day. We don't think it's easy, so we're still in practice mode, but we aspire to get better at that. And this is a great opportunity to find out exactly how to do this important work. So please join me in welcoming Alison and Aleja.
Thank you so much for that introduction. We're really excited to be here. And I just want to highlight the contribution of our other PI, Dr. Danielle Wayne. She's really the expert behind our knowledge of alum, and in particular, a case study on East Pond in the Belgrade Lakes. And so you'll see several slides with her photograph so we can highlight a large part of the work that she did in this project. Thank you.
It's great. Yeah, so this is really a interdisciplinary from three different perspectives: social scientist, physical scientist, and a natural scientist, which has really been fun. So I'm Alison, and I'm going to start us off talking a little bit about what our project is, take you through the types of research that we're doing and some of our findings, and we welcome questions at the end. So our talk, Navigating Water Quality, Understanding the Impact and Perceptions of Boat-Generated Waves on an Alum-Treated Lake in Maine. We also wanted to acknowledge our funders for this project, which are through the Maine Water Resource Research Institute, or the WRRI program, from the 2022 research grants. Thank you. All right, so this is our study team. So of course, Aleja and I are here. This is Dr. Danielle Wayne. We are also joined in this research by two of our students at Colby College. Thank you. But Emma Rothwell, we also have Margot Kenyon, so we can't underestimate the contributions of our students. But this work that we've done has really been informed by a stakeholder advisory board, and it's really critical to the science that we do, that we're being informed by the public and by people who are being impacted by the results of our research. And so our stakeholder advisory group consists of individuals from the organizations that are listed here: Camp Manitou, which supported our data collection efforts, North Pond Association, East Pond Association, Maine Lakes, the LEA group, the Maine Department of Environmental Protection. So these folks have been incredibly helpful to us. So I wanted to acknowledge them. All right, so you might be thinking, what is alum treatment? So I'll give you a little bit of context about our study. You're probably familiar with algae blooms. So algae blooms occur on Maine lakes. They can degrade water quality, sometimes making a lake really unswimmable. We tend to not want to spend a lot of time in a lake that is experiencing an algae bloom. You can see an example of an algae bloom. This is from North Pond, which is in the Belgrade Lakes region, which is very close to where we're coming from. This lake and others around it will sometimes bloom in the summertime when it's very warm. There's an excess of phosphorus in some of our lakes. These can be naturally occurring, or it can come from human sources. And when we have overloading of phosphorus, we can get eutrophic conditions. We can have an overgrowth in plant or algae, and this can deplete oxygen in the lake, creating this condition. So we know algae blooms can impact recreational opportunities. They can also decrease property values. And there's been a lot of efforts trying to mitigate through different treatment options, algae blooms. How can we minimize these from occurring? So one treatment option that is increasingly being looked at here in Maine and in other parts of northern New England is using alum. This is an aluminum derivative. This is a way to treat a lake to try to minimize algae blooms by binding that phosphorus, right? So essentially, you're distributing this alum into the lake. You can see a picture of a barge that's actually depositing alum into the lake. This is on East Pond, which is also in the Belgrade Lakes region. This is a lake that was experiencing yearly algae blooms, right? And so what this alum will do is it will bind the phosphorus and make it unavailable. It'll settle on the lake bed, and it minimizes those algae blooms, okay? So algae blooms have been really minimized in East Pond by an alum treatment that was done in 2018. So users came together, the East Pond Association in partnership with the Seven Lakes Alliance and community members to conduct this newer type of treatment called alum. And it was implemented, cost about over $1 million, right? This is kind of a big treatment to do, but the lake was really becoming unswimmable during some of the warmer months. So what we wanted to show here, right, this is the barge that was being used to distribute that alum, and a firm was contracted to come out in 2018 and treat the lake. There were 2 different treatments that were done. And what you see here are the transects that barge ran. The alum was distributed in deeper parts of the lake. And to our knowledge, this is the largest alum treatment in northern New England. So this is a really interesting case study as we're thinking about how we might move forward with other types of alum treatments, and are there things that might be potentially impacting the alum treatments of lakes. So that brings us to the goals of this project. The first goal of our study is to understand attitudes of residents and users of a place called East Pond of alum treatment lake as a water quality solution. Okay, so in effect, what do people think about using alum treatment, right? This is a fairly new technology. Because of the efficacy of the alum treatment, it effectively stopped the algae blooms, but also the large investment, meaning it cost on a pretty small area over $1 million to implement this. Are there things that might be impacting that alum treatment, right? We'd like to minimize any disturbances to the efficacy. So are waves potentially impacting the alum treatment, okay? We also wanted to determine what are the relative contributions of wind-driven waves compared to boat-driven wakes, right, in an alum-treated lake. So we did measurements of boat wake heights and velocities underneath those waves, and we modeled sediment resuspension under different wind and boat use conditions. And then finally, we characterized preferred management solutions among users and stakeholders of the lake. So this has been a fairly short timeline on this study. We just started it really a year ago. So we started out last fall, and what we did was do some field measurements, right? So we went out to see, well, what's actually happening if we have these different types of wave conditions, whether they're being generated by boats, whether they're wind driven, right? What's happening on the lake? So we did a bunch of measurements. Aleja will show us some examples of that in a little bit. We did modeling during the winter and spring conditions. We kept up some sensors and different types of instrumentation that Aleja knows more about. And then in both kind of the summer and then into this fall, we did a user perception survey to gauge attitudes towards, what do you think about the alum? If we are finding these impacts to the alum treatment, what are the ways that we might manage this? So this is really important because it helps us understand, should other lakes put out this type of investment for alum treatment? Are there things that might be impacting an alum treatment that we might need to mitigate for in the future? So we're going to walk you through 4 research questions, sort of one at a time, and then we'll talk about the results of each of those questions in turn. So our first research question is alum an acceptable water quality treatment in Maine lakes? And of course, we're using our case study on East Pond in the Belgrade Lakes as one of the largest alum treatments in New England. So I'll talk about our survey that we did and community engagement to understand this question. So we did a lot of community engagement in this project, and I would say that this was really led by our undergraduate students. So I wanted to sort of shout out to both Margot and Emma for that. We wanted to characterize attitudes towards this treatment. We wanted to track what's actually happening on the lake. How are people using East Pond? Do people know about the alum treatment? Do they know that there might be impacts to the efficacy of the alum treatment? We worked with the courtesy boat inspectors. That's what you see happening right here. Typically, courtesy boat inspectors will be looking for things like invasive species that might be caught up in a propeller. But they also helped us track the types of boating use on the lake. We interviewed people at the boat launch on East Pond. There is public access to this lake through one boat launch. And then we surveyed lake users, both primary and secondary homeowners, as well as people that are visiting on just a day basis to East Pond. So we used best practices for survey design. We have to go through an ethics review through something called the IRB. So that gives us permission to work with the public and to characterize information that people give us about their, not only their attitudes, but also their sort of boating use patterns. So that helped us to generate a survey instrument. And we sent out a survey in 2 different ways. We did a mail survey to all homeowners, everyone living within 5 kilometers of the center of the lake. So we got all of the addresses, whether it was a primary home or a secondary home. We were sending mail across the pond, meaning over to Europe in some cases, because there are secondary homeowners all over the world in this area. So we were surprised at that. And then we also did an internet-based survey. So people could take the survey in either way. And our survey had 4 different sections. There were 18 questions in total, asking about things like not just the alum treatment, but other boating types of boating activity, demographics, perception of boating management. Overall, we had 192 surveys that came back. The surveys keep coming back, even though we have finished the study or they're finished with data collection. So anyone that does this type of work might be familiar with that. And so about half of our responses came in via mail and half came in online. So our undergraduate students have been diligently entering data from the mail surveys. Okay, so we collected our data. I'm not going to spend a lot of time on this slide, but I did want to note that when we take in our full sample, right, so a little over 190 responses overall, sometimes our sample doesn't match what the general Maine population looks like, right? So I wanted to just give you a snapshot that the population of people that took our survey tend to be people who have waterfront property, okay? So they're older and more likely to be retired, okay, than the general Maine population. They were more likely to be male. 68% of our sample has a 4-year college degree or higher, okay? And it's a relatively high income population. 59% have a household income of over $100,000 per year. And then 45% of our sample, right, this is their primary residence. So that means a little over half of our respondents, this is actually their secondary home. This is a vacation home that they have on East Pond. And we thought that that was important because it helps us characterize sort of who this sample is. We also had 5% of our surveys that were returned that were incomplete, people that lived within 5 kilometers, but noted that they had no access to East Pond. They didn't have waterfront property, and therefore East Pond might not be part of their day-to-day life, not have a real strong connection to East Pond, even though they were within a very close distance. So this is not a place that has, I would say, a very large amount of public access. Okay. So we gave people information about the alum treatment. We weren't sure if people knew that this had happened. There had been some public outreach when this occurred, right? So this is a pond association and a nonprofit had worked together to disseminate information, but we wanted to make sure that everyone was starting with a little bit of information about alum. So we gave, this is a very short subset, but we gave people information about alum treatments, why they're used, and that there had been a treatment in 2018 on East Pond. We find that the strong majority of our respondents are really supportive of the alum treatment. This was actually a little bit surprising because in some of our pilot data collection, we had thought, well, maybe people would be really concerned about this. You know, it's a chemical compound, are people concerned? But we look at the people's attitudes. This is very positive, right? And blue here is positive, right? I mean, this is a large majority of the population that has like generally, not necessarily related to East Pond, but generally is very supportive of using alum to treat algae blooms, right? So we think this is a pretty important finding. This is one of the first studies that has gauged perceptions of alum. However, there is some concern and some risk perception, right? So people were given opportunity for open response, and we also conducted interviews. People said things like algae blooms, they were intolerable, right? A lot of people talked about how the lake was not swimmable in August and some of the summer months. Thank goodness for the alum treatment. Other people noted some of the risk. Will this be another PFAS situation 5 to 10 years from now? Meaning, do we have enough information to be able to safely do these types of treatment? We also know that the way and the processes that we use to implement new types of treatments can influence how and whether people support new types of infrastructure, new types of environmental management. Just about 2/3 of our population knew that the alum treatment had occurred, meaning about 1/3 of our population had no idea that this even happened. So people that are recreating on the lake, maybe they own a home on the lake, didn't even know that there had been an alum treatment. The people that did know, about 80% were knowledgeable and were aware of this before it was ever implemented. All right, so there's a fair amount of user knowledge, but not everybody knew. But we also wanted to note that processes, decision-making processes are really important, right? So one person said, well, the use of alum is a complex issue. It's situational. I think that they had a public meeting, but the decision had already been made. And what we show in this graph here is that people who are supportive of the alum treatment on East Pond are much more likely, that's what we're showing in green, to say that they had an opportunity to voice their opinion before the alum treatment had been implemented, okay? Versus people who are opponents of the alum treatment or they're not sure are much less likely to have had an opportunity to weigh in, right? So if we're thinking about using alum in other contexts, it's really important that we're thinking about the processes, the decision-making processes and the types of public engagement opportunities that are being provided, right? Overall, people who are informed about alum are actually more supportive, right? So we see higher levels of support of people that are informed, previously informed about alum than people who were not. Okay. We also wanted to know, well, what are the risks that people identify around alum treatments, okay? So more than 90% of our respondents think that controlling algae blooms is really important. People seem to think that the alum treatment was really a benefit for swimming and types of recreation on the lake, but we wanted to know, well, what are the risks, right? So what we're looking at is this column here. Where are the harms? Where are the not sures? And what we note is that people tend to think that alum is good for humans, but maybe is a little more risky, or they're not sure about what the environmental implications might be. So we think this is an important for public policy decisions as well. All right.
So we're going to switch gears a little bit and think about how alum might be disturbed by boat wakes. And this question is really driven by the stakeholders of East Pond, who were worried that there might be an issue with waves either driving sediment suspension or burying the alum in East Pond. And so one of the things that started was our colleague Danielle Wayne back in 2019 did some initial testing to look at how deep the propeller wash from a boat goes into the water column in terms of possibly disturbing that sediment. And so here's a series of experiments where they were looking under wake surfing, wakeboarding, and water skiing conditions of a boat and measuring how fast were the velocities at the bed of the lake in the deep part, so around 7 meters depth. And what they found is that overall, over all three cases, there wasn't any large signature of that boat wake at 7 meters depth. Even under the wake surfing condition, which created the biggest waves, they were only seeing significant signature of that wake about 2 meters below the surface. And for both wakeboarding and water skiing, it only kind of went about 1 meter below the surface. And so that study kind of showed that there was not any measured impact with kind of their one set of experiments in the deep part of the lake. But the other question was, well, are we seeing impacts in other locations on the lake? And what else might be causing waves that could be driving changes to this alum treatment? And so we started to think about, well, if we're going to look at the wind climate, what is that relative importance? And so in the fall of 2022, we set up a series of experiments on East Pond, shown here, with the shallow location and the deep location. So at our shallow location, we set up a range of sensors to measure water level, how fast the velocity was at the bed, and wave pressure, water pressure, so we could get out wave height and period. And then we would also measure turbidity. We did put out the same sensors in the deep water on the subsequent day. And what we would do at this white arrow is we would run the boat under different wake conditions 5 times at each location. So what we had is water skiing, where the boat was moving pretty fast, 30 miles per hour, but relatively shallow in the water. It was high up on the surface. And this is the wake that it would create behind it, which is a pretty small looking wave. You have that kind of rooster tail and then the wake spreading out. On wakeboarding, however, we added ballast to the boat, so it's heavier in the water and is able to produce a larger wave height that you can see here that's preferred for wakeboarding conditions. And then our last case is actually the wake surfing. In this case, we actually slow down and are only going 10 miles per hour, and we use both a lot of ballast and a hydrofoil to create this larger asymmetrical wave. So this is kind of showing one side of the boat, the wake behind the boat, where we get this much larger wave for the wake surfers. So here's a video of kind of that wave that develops. And you can see that strong asymmetry where on this side, there's this well-developed wave for surfing, and the other side, it's a lot more kind of white water wash. And this is just a still image of that. And so when we talk about the measurements under wake surfing, we're measuring what's happening underneath this big roller as it propagates across the lake surface. Okay. So one of the things we put out was a series of instruments called tilt current meters. And here's an image of it. And it basically is just something like your phone. It has a 3-way accelerometer and it's floating at the bed, and whatever direction the current is going, it'll move. And based on that, we can actually pull out the velocity, how fast is the water, and in what direction the water was flowing. And so this is actually the raw measurements that we recovered from this instrument here, located here in our shallow water deployment when we were wake surfing. And we clearly see the 5 runs that we did, and we get elevations of water velocity at the bed up to 10 to 12 meters per second. And so we were very happy to kind of clearly have that signal measured. But the other part we were interested in, of course, was, well, how big is that wave? Unfortunately, it's very hard for humans to visually estimate the height of a wave. We tend to overestimate it, just like we tend to overestimate the size of the moon, how it looks really big to our eyes, but when you take a photograph, it's really small. Same thing can happen with wave heights. So we had a number of other instruments located, again, along that transect. And here is the sample of what's measured. So what we're showing is water level elevation. So how high is the water going up or down as that wave is passing? And so to actually calculate the wave height, you take the difference between the crest, the peak of the wave, and its trough. And so here's an example. The biggest wave that was recorded at this sensor under this run was about 35 centimeters. Okay. We ran the boat 5 times. So I take every single measurement of those 5 runs for a given instrument and calculate an average wave height for wake surfing, as shown here by the black line. And we then are obviously getting a range of measurements, right? Each of our instruments has a kind of maximum peak wave that we calculate that's averaged over the 5 runs. And then we can average between the different instruments that are closest to that wake and calculate kind of an average maximum wave height under wake surfing conditions, wakeboarding, and water skiing. Of particular note, in the shallow location, we get our largest wave heights of about 30 to 34 centimeters. And our velocities are also largest under those, peaking upwards of about 13 centimeters per second. Okay. And so we actually use these data to then think more about some of the numerical modeling and consider what might be the relative impacts of wind-created waves compared to these boat wake-created waves. And that drives our next research question, which is kind of looking at that relative contribution, right? The boat wake waves are being run in the summer, primarily through a very few number of actual boats, versus the wind is actually blowing year round and has a whole range, right? Daytime and nighttime, and can create large waves. So to do this, I use the numerical model Delft 3D. It's a free open source model. Technically, anyone can download it. It's fun. It also has a lot of annoying parts, but what you can do is actually simulate at every single little grid cell here, the hydrodynamics. So what's happening to the water? You can also simulate the sediment transport. So how is the sand and silt moving around? And how does that then change over long term the bed elevation of your lake? And so here's the grid I used. And the grid cells range from about 100 meters by 100 meters to much finer scale within the area of interest. And the reason I have a range of grid cell sizes is because it makes it faster to run on my computer. And so first we started with thinking about the wind only case. So what happens if we were to create a model and run it for an entire representative year? So I create a representative wind climate that's kind of the mean winds each month, plus an average storm. So not a really large nor'easter that we see every 10 or 20 years, but something that we see more frequently. And in this case, that's going to be about 13 to 14 meters per second coming from the northwest. And here are the outputs of the model of that storm on April 28th, because I'm running the model for a full year. And the colors here are showing wave height. So the bright colors are showing wave heights of about 25 centimeters. And so what we can find is that with that kind of northwesterly storm, we're getting larger waves, not surprisingly, in the southeastern portion of the lake. And this over here is just the wind rows that I calculated based on the nearest long-term wind station. And what we're seeing is that there's a very strong dependence of kind of winds coming from the north, from the south, and then our bigger winds are kind of 5 to 10 meters per second, coming much more from the north and westerly, with very few winds coming from the east, okay? And so that's what's used to drive this year-long model. And we can look at other measurements, not just our wave height. One of the important things when we talk about how sediment moves is the bed shear stress. The bed shear stress is going to be created by the interaction of both our waves and any currents that are being created in the lake. And the key thing when we talk about sediment movement is we have to exceed a critical. And once we've exceeded it, we can start moving things. But until we exceed it, nothing really happens to the sediment. And so what we show here is a plot of kind of the maximum bed shear stress on that same storm day. Okay, so back in April, what we're seeing is that along the shorelines, we're getting very high levels of bed shear stress, but within the deeper parts of the lake itself, even at our shallow site, it's very low bed shear stresses that are not large enough to mobilize sediment. One of the things that's important to think about then, of course, is, well, after an entire year of waves being created by wind, how much does it actually change the lake? Is it actually moving things anywhere? And that's what this graph is showing us. So everything in kind of that purple is areas where we've had deposition, where more stuff has been put down. And then everything in orange are places where we've had erosion, where things have been removed. And what we can see is that about 99% of the lake has almost nothing happening. It has a mean deposition of 1 millimeter. So it's a very, very small amount of sediment, kind of got put down on most of the lake. And in particular, if we look at our shallow location or deep location, in the deep location, we have even less deposition. It's only 0.1 millimeter. But our shallow location, because it's quite close to the coast, where we have a lot of those large waves that we're developing, we actually see a bit more erosion happening right near the edge. Now, some of this is due to the fact that we created this model without any tuning. I didn't add vegetation. I didn't add breakwaters or riprap or sills or anything that would help bind the sediment at the shoreline, which we know exists on East Pond. So most of this kind of erosion and deposition that's happening right around the edges, it's better to think of it as a potential place where there might be issues, not necessarily where there are issues. And with this model, we can add that in. We just haven't done it yet. So the next thing we actually did was simulate the boat itself in the numerical model. So this is showing for our shallow case with the wake surfing. The little pink star or square is the position of the boat. And what you're seeing is the water level going up and down. So the purple is when the wave is high and the orange is when it's low. It's a little bit easier to see this broken out into discrete time steps. So T is just showing us once the boat starts moving at T equals 0 seconds, every 20 seconds, here's that boat moving through the numerical model. And we can see the elevation of the water shown in these kind of concentric circles of the wake spreading out behind the boat as it's moving. More easily, we want to think about that bed shear stress, because again, if we want to actually move sediment or change that lake, we need to be able to have a large enough bed shear stress. So what I'm showing here on the left is that old image of that maximum bed shear stress we got under our big or our small storm with the wind only. And then here on the right-hand side is the maximum bed shear stress that we get from the model under the boat. And what we can see is that there's actually an order of magnitude difference, that you're going to get much, much larger bed shear stresses and potential for erosion under our storm conditions than we are in our boating conditions at this part of the lake. Probably the easiest way to really compare how well is our model doing is to actually validate it and use the data that we collected in the field to compare to. So here what I'm doing is I've taken the data from one of our wave sensors at our shallow location, shown here in black. And we can see the change in water surface elevation, which again is showing us our wave heights. We then compare it to the model output at the same spatial location under that boat. And what we find is there's actually remarkably strong alignment between these, in that we get very similar estimates of wave height at the same location. The duration is similar and the periods are also similar. This gives us a much better confidence in understanding that our model is doing a reasonably good job at representing the boat within its domain. So some of the key takeaways that we found from both the field measurements and our numerical modeling is that yes, wake surfing is going to create waves that are about 2 times the height of water skiing waves. And in shallow water, we do see elevated velocities at the bed. However, the bed shear stress associated with that is not high enough to necessarily mobilize sediment. And based on our turbidity measurements, we had no evidence to support that there was any movement of sediment. In addition, one of the things we noticed is that at our shallow site, there was a lot of vegetation, so plants, and mucky sediment, or if you're a geologist, we'd say pretty silty. And as such, there's actually a lot of dampening of the wave heights as it's propagating away from the boat. So if we look at the wave heights, they actually get smaller pretty quickly from further distance of its origin. One of the cool things is we've now demonstrated a way to simulate these boats within a free open access numerical model, Delft3D. And the interesting part is that our mean wind climate creates waves that are a similar order of magnitude to what those boat wakes are, and that storms could potentially be creating much larger sediment movement and erosion than these boat wakes.
All right, so although the modeling and field measurements show that storms have a greater potential for sediment movement, which could potentially drive alum burial, we're aware that this will differ in other contexts and in other locations due to varying wind climate, geometry of the lake, vegetation, or sediment composition. Right? So this is a case study in the conditions that Aleja just described. There could be other environmental impacts from boat wakes. We only measure the possibility of sediment dispersal at the lake bed, okay, underneath the boat, not at the shoreline. So we still wanted to use this opportunity to gather pilot data on public perceptions of how we might manage boating activity if we did find that boating activity was, let's say, having an impact on a particular lake and what the sediment was doing underneath, right? Meaning, would our alum get buried? Would it impact this alum treatment? Right. So our final research question is, does the public support boating regulations which might minimize benthic sediment disturbance on an alum-treated lake? So we wanted to gauge what type of activity do people do on East Pond? Is this a real boating community or not? And we find that there's a lot of casual recreational use. The majority of the population does engage in some type of boating, but it tends to be recreational or speed boating. Very few people engage in wake surfing or wakeboarding. This is a pretty small subset of the population. So most people are doing more casual activities, and they're doing them quite often. The plurality of our sample is using the lake like every other day, right? So we have a lot of use that's on the lake, even if it's sort of casual recreational use. We also found that the majority of both primary and secondary homeowners are operating motorized boats on East Pond. So boating is really important to the community. We looked at attitudes towards motorized boating, and we find that the majority have positive views towards boating, right? So people are pretty supportive of allowing access for motorized boating. Okay, so this is maybe some indication of how people might feel about different types of regulatory measures, okay? Motor boats are the most frequently used, right? So most people are using a motorboat, followed by types of fishing boats or pontoon boats. Very few people in our sample are using wake boats, but they use them often. Okay, and we think this is largely driven by some of the camps that surround the lake, which have access to some of these wake boats. They're not typically launched on a sort of a day use capacity. So we asked about risk perception of motorized boating, right? There's lots of things that might come up. People talk about maybe infrastructure damage, like my dock is being damaged from motorized boating. But what we're really interested in for this study are, how do people perceive the impact of boating on impacting shoreline sediments, lake bed sediments, and do people perceive risks to that alum treatment? Okay, and so what we're learning here is that people tend to think that there's sort of benefit or no impact from boating on some of their shoreline living and enjoyment of the lake, but maybe a little more risk that maybe boating is harming some of those shoreline sediments. People are very passionate about some of the impact on the shoreline, which makes sense because that's where most people are coming into contact with sediments, right? People aren't necessarily looking at the lake bed. But people are concerned about the impact of boating on lake bed sediments, but they're not really concerned about how boating might impact the effectiveness of the alum treatment. Now, provided we didn't give a lot of information about what that impact might be, because our data hadn't really shown a strong association of motorized boating on sediment disturbance and burial. So we had to sort of pose this open-ended, is this something that you're worried about? And most people aren't really thinking about this. They're not really sure. This is not something that's in sort of the public eye. We worked with our stakeholder advisory group to look at lots of different regulations of how, wake boats, for example, wake boats produce these very large waves, as Aleja was showing you. How are boats managed overall? What are some of the different regulations? And are there specific regulations that might affect wake boats in particular, which have the very large wakes? And so in Northern New England, there are some different regulations that are impacting wake boats. Right now in Vermont, there is a draft rule where the lake must have, to be able to use a wake boat, they must have 50 contiguous acres. You must be 500 feet from shore. The water must be 20 feet deep or more. In New Hampshire, this has been considered, although there hasn't been enough evidence in New Hampshire to support legislation to limit wake boats. And then here in Maine, there has been proposed legislation, which is currently in review in a committee to better understand what some of the impacts from wake boating might be on the lake overall, not just related to alum, of course. Okay, but we considered we considered regulations to limit wake boating. We also evaluated attitudes towards, existing regulations such as, the 200 feet from shore, maintaining headway speed, which basically means when you're 200 feet from shore, you have to go slow and have a no wake zone. And we also looked at attitudes towards a rule that's coming into effect where anyone under the age of 25 from here on out would need to go through a mandatory boater education course. So we find that overall, people have generally positive attitudes towards managing boating activity, even though they support boating. Mandatory boater education, people are generally supportive, but what the red shows here is that there are a lot of people with very negative opinions. So what does this tell us? It's polarizing, right? There's not a lot of people in the middle. People are sort of here or here. No wake surf zone. So we said, we mentioned to people that there was proposed legislation in Maine, which would ban wake surfing boats in less than 500 feet from shore and less than 20 feet water depth. And again, quite polarizing, right? The majority support this type of regulation, but a lot of people think that this regulation goes too far. And then people are very supportive of our existing laws, which maintain water safety zones, which are 200 feet from shore. People also use this opportunity to air grievances about boating in general, like we should ban jet skis or lower the water limit or lower the horsepower of boats, even though we didn't ask about those things. So we wanted to know, well, why are people opposed or supportive of these types of regulations? So I won't spend a ton of time on this, but just to mention, with water safety zones, these are our existing regulations that you have to go slow when you're close to shore. Right? People think that they're very hard to enforce. And people also think that most people can't really judge 200 feet, right? So those are some of the biggest gripes that people have with this type of existing regulation. But on the other hand, a lot of people think this is common sense. We should go slow. There's a lot of concern over safety. People are swimming close to shore. Well, what about this proposed regulation of no wake surf zones, right? 500 feet from shore and more than 20 feet of water. And we find that a lot of people, what we show in the red here, right? So more than 50% think that these are really too restrictive, okay? People think that this is a good thing. It might minimize erosion and shoreline disturbance, for example. It might minimize some infrastructure damage. But again, enforcement and compliance would be very challenging to execute. So these are some of the reasons why people are opposed to this type of regulation, which is currently under consideration in this state. And generally, people support mandatory boater education, although again, people think that it is too restrictive, even if it is a good common sense rule, and that enforcement and compliance, people weren't really sure if that would be effective and thought maybe that all people should have certain types of education, not just people that are 25 and under. And then the last thing we wanted to share is Dr. Wayne, who's pictured here, took a look at the proposed regulations here in Maine and said, well, what would that actually mean for our state, right? If we had that regulation enacted, how many lakes would we still be able to go wake surfing in, for example, using one of these specialized wake boats? So we have about 6,000 lakes in Maine. We only have bathymetry data for about a third of them. But if we base a regulation on what's been proposed in Maine, or which is even a little more strict, what has been proposed in Vermont, we find that based on the Vermont legislation, right, we would only have 467 lakes that would remain available of the 6,000 in the state for wake boating. And then if we propose it based on the Maine rule, which is under consideration, we would have more lakes. We would have 700. There are more lakes that would be available, but still a smaller proportion than what's available overall, right? So we know that we would be limiting a large number of lakes from wakeboarding and using wake boats. Okay, so to wrap up, we wanted to note some of our key takeaways. One is that people generally support alum treatments. Even if you don't have prior knowledge, people tend to view it favorably. And people's primary area of uncertainty is around the impacts on aquatic life, not so much on human safety. This is important because some of the lakes nearby and throughout Maine are considering using alum on lakes that are actually public water, drinking water supplies. Okay. Boating impact on alum treatments is not an issue people have really heard about or thought about. There's a very high value placed on preserving the alum treatment because it's effective and people like being able to use their lake. So they are interested in preserving that, but it hasn't been a primary motivator for thinking about regulating boating activity, okay? Boating is very important in East Pond. People support reasonable regulation, but there's some concern about over-regulation, and it is highly polarizing. There are some site-specific measurements and modeling of East Pond, which highlights that storms potentially drive more bed level change than boat wakes. Okay. However, wake surfing does create waves locally equivalent to the height of potential large storms. And then we've created a new methodology for assessing potential boating and wind impacts on different lakes. And I will end there. Thank you.
Hey, Linda.
What a fantastic talk. We all learned so much. Can we give a clap again? And for those of you that had the opportunity to look at the what's going on in the chat, we're seeing people are doing back and forth and responding because there are so many different interesting issues that people are thinking about. And as the respondent from the team said, she said, my colleagues don't have this information, so is it okay if I go ahead and answer some of the questions that are in the chat? And isn't that great? Doesn't that just represent an example of how important it is to bring different disciplines together and to really learn from each other and trust what you're doing? So what an amazing, amazing example. So one of the issues people are interested in is, have you heard from your students? Did they, as they were doing this, did they work with the students from other disciplines? And could you tell from this whether they were changed in any way?
Yeah, that's a great question. You know, our students, we actually had a lot of students. We shared two of the students that worked on this most directly, but we actually had students from a lot of different disciplines come together, whether it was to go out on the lake for the day and share each other's research and sort of learn about the different disciplines. So we had biology students working with environmental science students, working with policy students, and computation students trying to learn how to use new software programs, learning how to talk to the public, even when sometimes it was controversial. Let me tell you, talking about regulations of anything in Maine or maybe elsewhere can be very controversial. So students had to learn a lot of new skill sets and really had to support each other in doing so. We couldn't have done this study without the support of our students, and there's a number of students I think here in the room, and you should know how valuable your contributions are to your professor's work, because that's really wonderful. Also, I know you've had some experience in the last couple of months.
Yeah, actually, one of the great things I've been able to do is I'm teaching a senior level environmental Science capstone research course. And the students in that course are actually working on projects that are outgrowths from this grant. So they're getting to kind of look a bit more at the data. There's one group that gets to use Delft 3D and do some numerical modeling. And the other groups are a bit more focused on using some satellite data to kind of look at the broader scale of lakes across Maine, as well as better understand what might be a first estimate of potential waves given Maine's wind climate across those 6,000 lakes. So I'm really excited to see the results from that at the end of this semester.
Amazing, very interesting. Do you know if the students are, is it changing their forward momentum in terms of what they think they will do, or who they, what kind of people they want to work with?
Yeah, I think I would absolutely say so. One of the students that worked with us quite extensively, Margot, was very interested in pursuing a career in this space, and she's actually gone on to work with one of our stakeholder advisory organizations out of this. And so she sort of took a second position to learn more about how the public is interacting on different lake-based issues, which was something she really didn't have any knowledge about prior to this study. And we have other students that are thinking about law school. They're also thinking about equity and justice. One of our students is very interested in equitable process and was very concerned that we might only survey people who had the ability to have a waterfront home. And she really spent quite a bit of time at the boat launch, making sure that we were providing access to people who just maybe can only come in for the day and might not have direct access to the community, and is thinking about pursuing environmental justice-based careers. And so I think she really enjoyed having the opportunity to influence a more equitable outcome of a research project.
Very interesting.
Could I call on someone here for a turn?
You sure can.
Yeah, I had just a quick question about the surveys. The first was on the first like question 1 surveys. I noticed that you had a category in which you distinguished people between knowledgeable about lakes and not knowledgeable. Is that a determination you made or a determination they made?
Yeah, that's a great question. We asked, that was self-reported knowledge. So we asked people if they, is this something that you're familiar with? Are you following different lake management options? And so people self-selected. People don't always accurately indicate their level of knowledge, but at least it gave us a gauge of how closely people are following this issue. And some people, I can tell you, are very informed. They have followed every decision. This is sort of, they're living and breathing this stuff. And others might just come up and use the lake for a few weeks each year and don't really feel that engaged or aware of the different opportunities and different water quality management actions. So we're trying to get a sense of people that are following this closely versus people that maybe are just hearing this for the first time. What is sort of your knee-jerk reaction versus your well-studied reactions?
And in kind of the same vein, when it comes to the other study in which we saw a lot of polarization, do you think that is an accurate reflection of the public attitude or a reflection of the people who took the time to fill out the survey because they had a polarized view of it?
Yeah, I mean, that's always a challenge with these types of studies. We had a 34% response rate, which is decent for a survey, which gives us a pretty good indication that we're at least getting a decent spread of the data. But of course, in any type of survey-based data, you're going to get people that feel really strongly about this topic on one side or the other. And so sometimes you will get an overrepresentation of people who have very strong feelings. So that is certainly possible. We've not done sort of a data weighting with the general population in Maine. Like, we know we're oversampled in certain categories that we mentioned. But again, if we're thinking about water quality treatment options, these are the people that tend to come out to public meetings. They might come out if there's proposed regulation, which there are, and there's been public comment periods. These are the people that tend to be engaged on both sides. So it does give us a sense of maybe what's the pulse of the community on some of these issues. Yeah, it's a great question.
So Linda, I have another question here, but I know we're also real short on time. Can we squeeze in one from me and one from you?
Yeah, shall I go ahead with one and then you'll do the last?
Yeah.
Okay, great. So one of the questions or points that someone made is alum treatments generally provide very rapid visible results. Do you think that as the early alum treatments age, we'll see a decrease in positive perception of them?
It's possible. They're pretty early studies in understanding attitudes towards alum. I mean, what we learned from this is that there are a small subset of people that are very well informed on this topic, but most people, maybe they've heard of it, but they're not real familiar with the details. I mean, even the two of us had to learn really about what was happening with alum, right? We depended on our colleague, Danielle Wayne, to really understand what was going on. So, whether their perceptions change over time, doing a longitudinal study where we're tracking attitudes over time, I think would be really useful, particularly as more and more lake associations start thinking about this as a relatively expensive treatment. And I know in our area where, some of the lakes that are public drinking water supplies are thinking about using this. And it would be important to know how we think about this if we're going to be maybe, potentially ingesting it. Maybe attitudes would be a little bit different. So this is really, I would say, a first pass pilot data collection. We have a little bit of understanding and we'd love to know more for our next study. Okay,
probably the last one, please.
All right, thank you so much. Excellent presentation. I might be a little biased because I'm a fisheries major, so I'm particular about the effect of sediments on aquatic life, especially benthic organisms.
Yeah.
So, has there been any study towards this? Are you seeing some impact already? I would like to know more about that.
So I'll take this, though. Probably our colleague, Dr. Danielle Wayne, is going to be able to best answer this with regards to lakes. At least within East Pond and some of our kind of deeper lakes in the Belgrade area, which are the ones I know at this point, there isn't high rates of sedimentation in general within kind of the deeper locations. And that was what our numerical model found, especially when we account for the fact that there's ice covering the lakes for large parts of the year. In our deeper locations, we were seeing a millimeter or so of sediment deposition after an entire year. So from the perspective of worrying about that's potential impact on aquatic animals, I would have to bow to a fisheries expert. My sense is that's not a major issue if it's only a millimeter of sediment over an entire year, but I don't know that as much. I know that there have been a lot more studies on that side with regards to marine locations. I'm not as informed with regards to that on the lake limnology side.
Yeah, I think there have been some studies that show populations tend to bounce back, like with respect to alum treatment, for example, that populations tend to bounce back after an initial shock. But yeah, I think that we would not be the ones to speak authoritatively on this. But the reason that we asked about risk perception with those, which may be where you're thinking about this, is that that's what people were telling us in the field as we did some of our pilot interviews and started collecting data. That's what we were hearing from the public. And that's how we generated the categories of things to ask about in our survey to see, do a lot of people care about this? And if so, sometimes that can help direct research funds to a specific area, or that can help us with public education and public outreach mechanisms when there's research to support or debunk some of those perceptions.
So I think we're at time, and if you have questions, I'd encourage you to come up and ask them, but why don't we close now and thank Alejandra and Alison again.